Good morning to all. I am here to present my seminar on the topic machine learning in embedded systems. My guide is Mr. Ando Manuel, Assistant Professor, Department of EC. These are my contents. Now we are going to the introduction. We all know that recently AI applications like Apple Siri or OK Google become more popular. I don't know whether you have tried it or not. Even if you turn off your mobile phone, and turn off your internet connection in your mobile phone, then also these AI applications will recognize your voice. How do you think it's possible? It's possible because of machine learning. Machine learning enabled on your embedded system. So, uh, by incorporating machine learning into embedded systems, devices can carry out operations like data analysis, prediction, and decision making. And machine learning models for embedded devices has limited battery capacity, computational power, and storage of embedded devices. What is machine learning? Machine learning is a subset of artificial intelligence that involves the use of algorithms to enable computers to learn from data and improve their performance on tasks without explicit programming. So basically, machine learning enables your computer to make decisions or make predictions based on its learning from a group of data. Machine learning has been adapted in several different areas for a number of applications such as image classification or natural language processing. Next we are going to see a little bit history of machine learning. That is milestones in machine learning. It was in 1952. The term machine learning was coined for the first time. In 1957, the perceptron was developed. A psychologist called Frank Rosenblatt was developed this perceptron. So, perceptron is one of the first algorithms that used the concept of neural networks. In 1967, a nearest neighbor algorithm was developed. In 1974, backpropagation was designed. So backpropagation is an important concept in machine learning today. In 1979, Stanford Cart first remote controlled robot was developed. In 1997, Deep Blue defeated world champion in chess. So Deep Blue was a supercomputer developed by IBM, and it defeated the world champion of chess Gary Kasparov in 1997. In 2006, the term deep learning was coined, and it was coined by Geoffrey Hinton. He's also named as father of deep learning. In 2011, Google Brain was founded. So Google Brain is a research group that focuses on machine learning, deep learning, etc. In 2014, Facebook developed DeepFace. DeepFace is an algorithm which is used to find similar faces in a photos, etc. In 2017, ImageNet Challenge was sparked. So ImageNet Challenge is an important competition in computer vision, and for the first time in history, and most of the teams participated in competition achieved 95 percentage of accuracy in 2007 17. In 2020, OpenAI announced GPT-3. So GPT-3 is more familiar to us in the name of ChatGPT. In 2023, OpenAI released GPT-4. GPT-4 is a licensed version of ChatGPT. Now we are going to see the classification of machine learning algorithms. So most of the machine learning algorithms are classified on the basis of data. So data is an important concept in machine learning. In the machine learning models are trained and tested in huge data sets. There are many types of data, including unlabeled data, partially labeled data, etc. According to the type of these data, the machine learning algorithms are classified into unsupervised, semi-supervised, supervised, reinforced, etc. As you can see, the supervised machine learning algorithm with labeled data sets requires a minimum computational architecture, while the rest of these machine learning algorithms requires a complex computational architecture. Now we are going to see what is an embedded system. So embedded system refer to a combination of computer hardware and software, extending computation beyond traditional devices such as desktops, laptops, etc. Each platform is designed for a specific application or specific functions within a larger system. So examples of embedded systems include washing machine, drone, pacemaker, etc. Now we are coming into the main part of this seminar, that is embedded machine learning or machine learning in embedded systems. So machine learning in embedded systems involves the integration of machine learning models and algorithms into resource constrained hardware devices. So we know that most of the embedded systems are very resource constrained. They consume say very low energy, low power, they have low memory, etc. Uh, so embedded machine learning focus on how to integrate these machine learning models into these resource constrained hardware devices. So the common ML techniques used for embedded platforms include SVMs that is support vector machines, CNN convolutional neural network, DNNs deep neural networks, KNNs K nearest neighbor, and naive Bayes. While model execution and inference process take place on embedded devices, the training of ML models like neural networks takes place on computing clusters or in the cloud. So we all know that in machine learning, the training of machine learning models requires more computational power comparing to the execution of these machine learning models. In embedded machine learning, a practice is that we train the machine learning models which is to be deployed on these embedded systems in separating computing clusters or in the cloud. Then we download these trained machine learning models and deploy it in the embedded systems. So now we are going to see some applications of this embedded machine learning. So the first application is image recognition. Image recognition is one of the most significant applications of machine learning. It is a method for identification and detection of an object in the detailed image through features. The second application is video surveillance. So we know that in most of the security-based applications, machine learning is used, and in most of these applications, video surveillance plays a major role. So, for example, the for in security-based applications, face pattern is used for unlocking safes, doors, etc. So this face pattern verification is done through machine learning in embedded systems. In the third application is healthcare. So healthcare is one of the applications of machine learning that has major societal impacts of machine learning on itself. Machine learning can solve the issues of rising costs of healthcare and help improve patient-doctor relationship. Now we are going to see some challenges faced on implementing these machine learning models in embedded systems. So the first challenge is energy consumption. As we know that embedded systems consumes a less power. At the other hand, machine learning models are very power hungry. So we can deploy the machine learning models directly into these embedded systems because we need to optimize these machine learning models for the requirements of embedded systems. So the second challenge is security. Even though these machine learning models are run on embedded systems, always most of the time, sometimes they need to be sent to the cloud, or sometimes they need to be sent to the cloud for retraining or retraining purposes, etc. So while sending this to cloud, there are chances for security risks. So the third challenge is latency. So I already told you about sending machine learning models or data into the cloud. So there are chances for latency in this sending process according to the internet bandwidth. And the fourth challenge is limited computational resources. So running complex machine learning models with large parameter sizes can be impractical or impossible. So as we know, most of the embedded system doesn't have much memory, computational resources, etc. So running complex machine learning models can be a challenge. Now we are going to see opportunities or solutions for the challenges we saw in the last slide. The first opportunity is quantization. So quantization in machine learning refers to the process of reducing the precision, that is number of bits used to represent numerical values such as weights and activations in a neural network model. And the second opportunity is pruning. Pruning in machine learning refers to the process of selectively removing certain parts, neurons, weights, or connections of a trained neural network model while maintaining or even improving its performance. So these quantization and pruning are software solutions for the challenges we saw. Now we are going to see some hardware solutions for the challenges. The first one is GPUs. So the thing with the GPUs is that they can parallelly process a number of tasks. So this capability of parallel processing can be used for machine learning purposes. Then the next one is FPGAs. So FPGAs are programmable devices that may be set up to carry out a variety of activities. They may be utilized to speed up machine learning systems. So now we are going to see an introduction to TinyML. So um, TinyML is a field of study in machine learning and embedded systems that explores the possibilities of implementing machine learning models in very low end embedded systems. So when we say embedded systems, we mean an embedded systems from a high end to low end. That is from Raspberry Pi to ESP32. So we all know that ESP32 doesn't have that memory power of Raspberry Pi. So TinyML is a subfield in embedded machine learning which focuses on implementing machine learning models in low-end microcontrollers and embedded systems like ESP32. So now we are going to see some advantages of TinyML. First one is low latency. Since the model runs on the edge, the data doesn't have to be sent to a server to run inference. This reduces the latency of the output. Low power consumption. As we discussed before, microcontrollers consume very little power. This enables them to run without being charged for a really long time. Low bandwidth. As the data doesn't have to be sent to the server constantly, less internet bandwidth is used. Privacy. Since the model is running on the edge, your data is not stored in any servers. So now we are going to see some current world examples of embedded machine learning. So the first one is wake word detection. We all know about OK Google. So OK Google is a wake word detection. The next one is car crash detection. So most of the Android phones releasing now does have this feature, that is car crash detection. Your phone automatically alerts authorities when your car crashes. But unfortunately, this feature is not available on India. It's only available in United States. And the third application is step counting and workout detection. So basically it means wearable devices like your smartwatches. So we all know that there is self monitoring enabled in your smartwatches. So machine learning is used there for counting your heartbeat, uh, SpO2 levels, etc. So now we are going to see some companies involved in the field of embedded machinery. So the first one is Apple. We all know that Apple uses machine learning in its smartwatches to run health analysis. So we all know that we all hear about the news of Apple Watch saving lives of people. So most of the times, what enables this Apple smartwatch to run health analysis is machine learning. So the machine learning enabled in smartwatches. And the next company is Nvidia. So Nvidia is a USA based company. It developed Jetson modules that can handle high intensive computation, which are essential for machine learning applications. Then there is Google. As we know, Google is a USA based company, and Google has done some significant contributions to the field of embedded machine learning. So it developed TensorFlow Lite for running machine learning models on resource constrained devices. So TensorFlow Lite is a framework for embedded machine learning. And then another company is ARM. So ARM is a UK based company. So ARM developed Ethos U55, which is a micro NPU, micro neural processing unit, which helps in accelerating machine learning tasks. So now we are going to see some recent developments in embedded machine learning. So I already told you about GPUs and FPGAs being used for these machine learning purposes. So after these GPUs and FPGAs, more hardware accelerators like application-specific integrated circuits, ASICs, and system-on-chips came into the scene. So one of such is Google's purpose-built ASIC Edge GPU, designed to run inference at the edge. Another is Apple's neural engine. So Apple's neural engine is a dedicated machine learning accelerator that is integrated into Apple's A series and M series chips. So Apple uses A series chips in your iPhones and iPads, and M series chips in MacBooks respectively. NVIDIA developed a module called Jetson. So Jetson modules are small, powerful computers and that are designed for embedded AI applications. They are based on NVIDIA's Tegra processors, which are optimized for machine learning performance. So now we are going to see some future challenges for embedded machine learning. So the first challenge is machine learning models are frequently sensitive to changes in the environment or the distribution of the data. Therefore, they may not always yield accurate results when used in novel circumstances. So we know that the real-time environment is constantly changing. So when we train a machine learning model in one particular real-time environment and we deploy it in another real-time environment which is similar to the previous one, there are chances for the machine learning model producing false results because the real-time environment is constantly changing. So that's our first challenge. So the second is not a challenge, it is more of like an opportunity. So we all know about quantum computers. So the good news is that quantum computing can be used in embedded machine learning because we know that quantum computers has the ability to perform computations substantially quicker than conventional computers. So this capability can be used for embedded machine learning. So before concluding, I would like to point you some resources where you can learn embedded machine learning. So the first resource is YouTube. So YouTube has plenty of resources for embedded machine learning. It has videos on TensorFlow, like TinyML, etc. And then there are online courses available by edX, Coursera, etc. on embedded machine learning. Then there are books And then there is Edge Impulse. And Edge Impulse. So Edge Impulse is a platform developed by Google for the purpose of embedded machine learning. Then there is another framework called TensorFlow Lite, developed by Google for the purpose of embedded machine learning. So these are my references. So by this, I'm concluding my seminar. Thank you.